Welcome back, everybody, to the fabulous world of the IETF RFC. So without further ado, let's move on to our featured RFC. This time up, the featured RFC is RFC 826, which is the Address Resolution Protocol. I put a little smiley face after that because I made a point in the last one to say that the typos weren't mine, and I went ahead and spelled protocol wrong. So I thought that was kind of funny. So this is not a protocol. This is a protocol. You find this, of course, with the search on Tools, RFC, and ARP. This one dates from November 1982. And the reason I put in there, don't ask me why, is because this one actually post-dates the RFC for ICMP, which I thought was a little strange. But there we have it. The official name for this particular RFC is not just the Address Resolution Protocol, but converting network protocol addresses to 48-bit Ethernet address for the transmission on an Ethernet hardware or on Ethernet hardware. And really the whole point there is that at this time, not everybody had the same kind of hardware. So let's hit a couple of high points. This is probably the simplest protocol you'll ever study or ever have the need to take a look at. It's just got two messages, a request and a reply, and that's it. And even they are really, really simple. There's a couple of updates to this. We'll talk about those here in a minute. And the whole point of ARP, what we are trying to do, is we are trying to discover a MAC address or a hardware address, which is just another name for the MAC address. And what we've done here is we've said, okay, I want to send a message to this particular IP address. I need to build an Ethernet frame. That's mostly what this is about. At the time, of course, that Ethernet was beginning to dominate the market, but it wasn't everywhere. And so we're trying to build a frame of some kind, and we need to discover the destination MAC address so that we can build the frame and send it there. Now, this is for nodes that you talk to or can talk to. So this means that nodes that are on your network or your default gateway, which also means that you almost never ARP for a node off of your network. Don't panic. I am not going to read this whole thing to you, but I thought this was kind of fun. They described the problem here. And when you look at the old RFCs especially, sometimes they stick in some fun language here. So the problem, the world is a jungle, and in general, sorry, let me try that one again. The world is a jungle in general, and the networking game contributes many animals. At nearly every layer of the network architecture, there are several potential protocols that can be used. Okay, so when you build an Ethernet frame, we know that you can encapsulate IP, you can encapsulate, IP version 4, IP version 6, and of course ARP most of the time. Those are going to be the big three. And the way that we differentiate those is with a type field in the Ethernet header. But of course, if we add to that the problem that back then, early 1980s, late 1970s, not everybody was using Ethernet, we can sort of see that there are additional problems. So that's why sometimes we refer to protocol addresses and hardware addresses rather than IP address and Ethernet addresses. Here are the messages that are described in the RFC. Now, you won't see, obviously, these. These are actually packets that I caught on a network. Here we've got the request and the reply. The request is notable because it uses broadcast destination and then unicast source. And then we've got the zeros in the target MAC address field because that's what we're looking to fill in. Something else that's very notable with the ARP messaging is that there's no IP header. So that's another indication that it doesn't live off of your network. And if you were looking to filter for these, trying to find these, don't filter based on IP address, filter based on MAC address. And in the bottom we see the response or the reply, and we see that all of the fields are now filled in. This is also unicast back to the original requesting host, and then all of the sender and target fields are flopped. Just for fun, here's an ARP table. So once you've ARPed for a destination node or someone, you update this particular ARP table so that the next time you might not have to ARP for that same node. And of course, these are the addresses that we use to build Ethernet frames. Most entries in this table will be dynamic, but I just for fun threw one in that shows you can make static entries in this table. Now, there are some other RFCs that are associated with ARP. 5227 is for the IP version 4 address conflict detection. So if you've ever been on a node and you see a little warning icon pop up in your sys tray that says something like an IP address conflict has been detected, well, that's because you just ARPed for yourself and found out that somebody was using your IP address. So, hey, that's what we call promiscuous ARP or ARPing for yourself. The guidelines for adding new values to the ARP field is kind of boring, but it's just if you want to expand the protocol, there's 5494 for you. No discussion about ARP, I suppose, would be complete without 903. RARP, which is called reverse ARP. It's not ARP, doesn't have anything to do with ARP. And the idea here is that I want to find my protocol or IP address when the only thing I know is my hardware address. So that's why it's the opposite. We almost never use RARP. Now, the most fun thing that I found in reviewing this RFC is a reference to the chaos protocol, an actual thing. Sometimes RFCs put funny stuff in there just as a joke. So it turns out that in the late 70s, early 80s, MIT was actually running the chaos protocol on their chaos network. And there's actually assigned numbers for the chaos protocol. So it's IP protocol ID 16. UDP is 17, by the way. And then we've got the MIT Chaos Net actually has a number associated with it. So I thought that was kind of fun. Well, that'll wrap up RFC 826 ARP. Remember that we broadcast requests and we unicast responses. And one last note, there is no ARP in IP version 6. Everything is multicast, neighbor discovery. I hope you enjoyed this particular sojourn into the land of the IETF RFC. Thanks for watching, thanks for listening, and may your packets always reach their destinations.